our moon is probably still geologically active. And they were shocked. The evolutionists were shocked by this.
Hello, everyone, and welcome to the Creation Podcast, the show where we discuss the science that confirms Scripture. I'm your host, Lauren, and I have with me today ICR research scientist and physicist, Dr. Jake Hebert. It's so good to have you with us today, Dr. Hebert.
Thanks for having me.
So today we are talking about a topic that I don't know very much about. So I'm honestly pretty excited to hear some different viewpoints on it and just what this is all about. So we are often in society just very excited about all things outer space. It's just so foreign to us. It's way out there. Almost everyone on the planet has never been there before. So we're going to talk about Mars. Specifically, we're going to talk about volcanic activity on Mars. So according to uniformitarian thought, Mars is billions of years old. I believe 4.5 billion is the exact number typically given. And the prevailing view is that it is dead today. What do they mean by dead?
Well, the thinking was that, in order to have like geological or volcanic activity, it takes energy to drive that. But planets eventually cool off. So, this is especially true for very small planets or moons. There's basically a few different mechanisms that you can use to keep something warm. It can retain original warmth that it had when it was formed. Radioactivity is another source of heat, and also something called tidal flexing, where you have these gravitational tugs stretching and squeezing the interior of the planet, warming it up. Now, one thing that as creationists we pointed out, there's a lot of small moons and planets out there where they don't really have a good explanation for why tidal flexing or radioactivity would work. And so these look particularly young. Now, Mars, I don't know if the case is as strong for Mars as it is for other really small bodies like Mercury and things like that.
Okay.
But they were surprised. In their worldview, they were expecting Mars to be geologically dead. It should have run out of energy a long time ago. But in the last 20 years or so, there's been some gradually accumulating evidence that Mars may still be volcanically active.
Interesting. Okay.
And most recently, they found they have a lander where they were able to infer that there's this giant rising lava plume inside the interior, and it's kind of like a blob of wax in a lava lamp, kind of rising up.
Okay.
It's what they call a mantle plume, and they weren't expecting that. Now they do believe, this mantle plume is located where they think the most recent volcanism occurred, which is in this plain that's near the equator.
Okay.
But they thought originally that had happened 200 million years ago. So they really weren't expecting this. They were kind of surprised by it. And this happens a lot. Routinely, we will see evolutionary scientists make statements like, well, we were surprised by this. We weren't expecting this. And it's usually because based on their evolutionary assumptions, and those assumptions turned out to be wrong.
And it sounds like a lot of their assumptions have to do with timing.
Yes.
And ages.
Yes.
Okay.
Yeah, long ages. Yes. Now, to be fair to them, this may not be a slam dunk argument that Mars is young, because radioactivity could probably account for this. It's not as strong an argument as it is for a really, small body like Mercury or some of Jupiter's moons. But it is consistent with recent creation. The fact that you've still got this volcanism going on Mars is consistent with it being relatively young.
Okay, so was this a surprise to you?
Well, I really hadn't thought about it that too much. I'm not surprised that the evidence is consistent with recent creation,
right?
But I hadn't really just thought too much about volcanism on Mars. Yeah.
So when we think of volcanoes, we think of the volcanoes here on Earth where just these massive eruptions, there's lava going everywhere, there's smoke and clouds and whatever else happens with volcanoes. Is that similar to what it looks like on Mars?
No, it's much more subtle.
Okay.
So they've got this rising mantle plume, and you're basically plumbed the depths of my knowledge on this. I don't know a whole lot about this particular example, but I can tell you that they were, they didn't expect that. And Also, there's other planets where this is an issue. Venus, they have recently concluded that it looks like there are active volcanoes on Venus, and they were not expecting that. And any way you slice it, Venus, the surface of Venus looks young. It really does look young. And back in the 1990s, the mid-1990s, they were shocked because they had concluded that the surface of Venus had to have gone some kind of catastrophe roughly 500 to maybe 700 million years ago. And they were shocked by that. They didn't like it because they don't like catastrophism. In fact, I've got a quote from a guy who said point blank, I don't like catastrophism.
Because then it allows for things like a massive creation or flood.
Well, exactly.
Yeah.
If you need catastrophism to explain the geology on Venus, or Venus in this particular example, maybe you need catastrophism to explain the geology on Earth. Mm-hmm. And what if that catastrophe involves a lot of water and sounds a lot like the Genesis flood? So you can see
messes things up for them.
You can see why they don't like that. Now, to be fair, I think recently some of them are saying, no, we don't think you necessarily need catastrophism to explain the geology on Venus, but pretty much any way you slice it, it looks young. And the fact that you've got active volcanoes on Venus is also consistent with recent creation.
Okay, so let's talk a little bit more in depth about what that looks like on a smaller level. So we're talking about volcanoes and volcanic activity on Mars. Obviously, it looks a little bit different, like you mentioned, than what volcanoes look like here on Earth. But the principle is one that's all over the universe, and that's heat and energy, all of that. So what about heat and energy might indicate to a scientist like yourself or evolutionary scientists, others, who are looking at something, what about the heat and energy might indicate that something is younger or older?
Right. Great question. Okay, so again, if you want to keep a body warm in space, there's basically three ways. One, if you've got leftover warmth from when it first formed, that's going to keep it warm for a while.
A while being?
Well, that's the question. We'll come to that point in a second. The other one is radioactivity. That generates heat. If you've got radioactive elements in the interior, and tidal flexing, that's the other one.
And what is that?
Well, that's, again, where you have these gravitational tugs that, let's say you've got a moon that's in orbit around a planet. There may be the planet may exert gravitational tugs on the moon's interior.
That kind of keep things moving.
Well, and it flexes it. It squishes it and stretches it, and when that happens, it heats up. It generates heat. Okay. And so that's a way that you can produce heat.
Kind of like the planet version of a human shiver, kind of that type of thing.
I guess you could say that, or moon. Okay, now here's the point, though. When you have very small bodies, they lose their heat to space relatively quickly. Okay, just because of the fact the surface area, you've got a large surface area compared to their volume, and the heat just easily escapes. Mm-hmm. The bigger the object, the less that's true. The longer it can retain that energy. Mm-hmm. So when we see in space small bodies like small planets or moons that look like they're warm, that have indications that they have a warm interior, and that's a very strong argument that they can't be billions of years old. And so that's why we creationists get very excited when we see indications of warmth in something like Mercury, or in some of Jupiter's moons like Io and Ganymede, even the dwarf planet Pluto, indications that there may be residual warmth there. So it's a problem if you believe in billions of years, because in many cases, they don't have a viable explanation for how those bodies could stay warm. Now, if they're just 6,000 years old, they could still be losing the energy that God gave them at creation.
Right.
So they could still be warm. But that doesn't work if they're billions of years old. And in a lot of cases, you can rule out radioactivity and in tidal flexing, or tidal flexing may not give you enough heat to do it, for that to work.
Okay, so looking at the surface of this argument and seeing, you just listed a lot, and I'm sure there are more, of small bodies that still are generating a lot of heat. They still are preserving a lot of that energy inside of them, and so they can't be more than a certain number of years old. So I'm curious, seeing the same evidence that we're seeing, evolutionists and uniformitarians who believe that things always happen at the same rate, they're still saying that the universe is X number of billions of years old. Why? Why are they okay with that, even though they're seeing this evidence?
Well, Here's part of the issue. Obviously, a lot of it's worldview. They just don't want to admit that the Bible might be right. Another part, though, is that depending on what you believe about the interiors of some of these moons, you might be able to get tidal flexing to work in some cases. The problem is we don't have a lot of data for the interior of these bodies.
Guessing at this point.
So maybe it would work, maybe it wouldn't. So they probably feel like they can still legitimately try to explain it. But one thing I've pointed out in a recent Acts and Facts article about Jupiter's moons, the four big moons of Jupiter, what we call the Galilean moons, they look young, relatively young.
Meaning they still have a lot of activity and energy?
Yes,
okay.
yes. And they've tried to come up with ways to explain it. And I've looked at a lot of the recent stuff they've done, and they don't have good explanations. And this is another example of why we try to keep up on the literature. Mm-hmm. So I talk about some of these newer developments, but they still don't have a good answer. They still look young, with a possible exception of Callisto. If you look at the cratering on Callisto, based on their models, they would say it looks old, but there's other things about it that look young. So, of course, I don't really trust cratering rates to give you an accurate age. So,
and what is that? What would they say that is?
Basically, the more craters you have, the older something is.
And what's the argument with that? Like, what?
It kind of makes sense. I mean, the longer, you've got bodies flying around in space. The longer a surface is exposed to that, the more impacts you expect.
Right.
So we don't disagree with that in a general sense.
Right.
But has it always been the same rate? If there was catastrophism in the solar system during the flood, you might have had a short burst of that. So they calibrate, they use the moon to calibrate the cratering rates, but the ages on the moon are coming from radioisotope dating, which we think is off. And so it's kind of a pyramid they've built. Mm-hmm. So as creationists, we don't disagree in general that the more craters you have, the older something is, but I don't think you can use it to precisely date something.
Okay.
Yeah.
Okay, so now we are going to step back and we are going to do our random science question of the day. So I'm curious for your thoughts on this one because there's been a lot of ink spilled on this, whether it's in the movies. We're fascinated with the idea of humans going outside of our planet, going to other places, whether it's in our solar system or even beyond. Even back, I watched some of the old TV shows like Star Trek and all of that. Yeah. Mm-hmm. So I'm curious for your thoughts. Do you think that humanity will ever set up a colony, even just a tiny one, on another planet?
Okay. Well, it's always dangerous making predictions, especially about the future, as Yogi Berra once said. But I don't think we will, not a permanent one.
Okay.
Now, I do think we can probably get the technology to get there to Mars. But the problem is to have a permanent colony, you got to have a source of food. You would have to have plants, probably. Mm-hmm. And you need to have a self-sustaining environment, with where you can get the oxygen. And that, they make it look easy on Star Trek because they're on a soundstage, okay? But they're not actually in a self-contained environment. And some of our viewers may remember years ago, there was this experiment called Biosphere. There were actually two of them, I think, where they said, we're going to try to do this. We're going to try to put people in a totally enclosed, sealed environment and see if they can make it. And we're gonna have hydroponics. We're gonna have plants in there. It was a total disaster. It didn't work.
Okay.
It just didn't work.
Uh-huh.
So I really don't think we're going to be able to do that.
Okay.
Now, could we get to Mars? Yeah. Could you visit Mars? I think so. I'm just not very optimistic that we could set up a permanent colony there. It's kind of funny. You've got people who've volunteered for a one-way trip to Mars, and it's like, dude, life is worth living. You need to come to Jesus. Don't throw your life away on a suicide mission to Mars,
Yeah.
And like I said earlier in another podcast, I think the Lord's going to let us explore that stuff when he comes back.
Yeah, so wait until
just be patient,
won't
okay?
die when we go there.
Yeah. But I'm skeptical that we're going to be able to set up a permanent. You see, by the way, that just shows you how wise the Lord is that he set up this environment here on earth. Mm-hmm. It's not as easy to make an environment for people to live in as you might think. And that the debacle that happened with those biosphere experiments, that shows you just how hard it really is. It's not as easy as they make it look on TV.
I'm curious, what were some of the issues they ran into with that experiment?
Boy, I think there were some sociological problems. I think somebody cheated and brought stuff in from the outside. I think they were having trouble with maybe the air. I don't remember all the details, but it was just a big debacle.
Yeah, basically, humanity can't create something the same that God
Yeah,
can.
I mean, it's you would think it wouldn't be that hard, right? I mean, again, the TV shows make it look easy,
Right.
but it's having an actual self-sustaining enclosed environment like that. It's tough. It's tough to do.
Well, that makes sense because this planet is set up so perfectly in ways that I can't even think of, but just the ones I can think of, like the gravitational pull is perfect set
Yeah.
up for us, and the pressure, the air pressure is
Right.
perfectly set up for us. The air we breathe, as far as the percentages of
Yep.
different elements that we're breathing, or just all of it is so perfectly set up.
Right, yeah,
and even
yeah.
just to fly in an airplane, they have to try to recreate
Yep.
some of what we experience on the ground. So I imagine that, well, and even the temperature here on Earth is very different. How different is the temperature here than on Mars?
Well, it's a lot colder. It's a lot colder on Mars.
Okay.
It's possible you can have temperatures like minus 90 degrees Celsius or something like that. I could maybe getting that wrong, but I do know that temperatures in some parts of Siberia occasionally get as cold or almost as cold as the surface of Mars.
See, that's
that
amazing.
gives you a feel for how cold it really is. Yes.
Well, and that's amazing too, because in my limited understanding, I could be wrong, I thought that heat would help energy continue. And so such a cold planet, wouldn't it slow down its energy even faster?
Well, you know,
or-
it's we're talking about energy inside the planet
Okay.
itself, the interior. Okay, you know, the atmosphere is very thin, so heat coming from the surface, it escapes to space pretty easily. So
Right.
it's not going to retain a lot, but you could still have energy in the interior that could maybe be powering some residual volcanism there.
Right,
Yeah.
right. Okay, so coming back to Earth, so to
Okay,
speak,
yeah,
we're
sure.
going to jump back into the topic at hand. So, just to discuss this a little bit further, and we've already touched on this, but I'm just curious if you have any additional thoughts on why does geologic activity in general indicate youth?
Well, again, usually that energy requires energy, and energy, warmth particularly, and bodies lose that energy over time. They still maintain a temperature, okay, but they get a lot colder. They're not going to completely. You're going to always have a finite temperature above zero, absolute zero, but they get a lot colder, and so especially small bodies, they lose that energy pretty quickly. And so if you see a small body, and when we say small, we can even be talking about our moon. Our moon is probably still geologically active. And they were shocked. The evolutionists were shocked by this. In fact, it was gospel for a long time that the moon has been geologically dead for like 3 billion years.
Wow.
And and so they just they were shocked. But there's more and more evidence accumulating that the moon is probably geologically active today.
What's some of that evidence? I'm curious.
Well, they left sensors on the moon by the Apollo astronauts to measure moonquakes. Actually, there's also something called transient lunar phenomena that people have been talking about for a long time, where people have seen flashes of light on the moon. That some of them could be meteorite impacts, but
Right.
others of them they think might actually be latent volcanism. Sometimes, in fact, there were reports of, they think maybe some gas might still be escaping from the moon. In fact, it was taken so seriously, NASA's done a technical report on this. But some of the really strong argument, I think, has to do with the moonquakes, because that's very recent. It's probably still going on today. And also, there are these geological features on the moon called scarps, and they're like little embankments or ridges. And they think those things form because the moon is actually the crust is actually shrinking a little bit because it's cooling. As it cools, it gets a little bit smaller. And so you get these scarps, they call them. And they think that happened fairly recently based on the craters. Like if you look at some of these, you have small craters that have been distorted by the scarps when they were formed. Now, the thinking is that smaller craters are probably relatively young because they ought to get hit by bigger meteorites over time and get erased. So if you see a small crater, they think that's relatively recent. And if you see a small crater that was distorted when a scarp was formed, that means the scarp is even more recent. Now, I can't give you a number for this, but this is we're talking relatively recent, okay? And so that's another very strong argument that the moon is a lot younger because they were not expecting it to have the energy to do this. The fact that it's still noticeably cooling off after 4.5 billion years, that they were surprised by that.
Okay.
So the moon, the same thing with Mercury. You've got all these examples in the solar system where you've got relatively small bodies that seem warmer than they ought to be if they're billions of years old.
Have we seen truly dead planets or bodies in our solar system?
I don't know. I mean, there's a lot of smaller objects out there that I don't know if we really know anything about. They're probably not geologically active.
Well, but I
can tell you this, though. I can tell you this. Pretty much everywhere we look, we see indications of youth. In fact, even on Mars, there's other possible indications of youth.
Like what?
Well, I don't want to be dogmatic on this point, but there's a question. Should Mars even have an atmosphere after billions of years? I came across an article in Scientific American, I believe it was in 2009, called Planetary Air Leak. And they were talking about how gases are escaping from Mercury and Earth. And that article asked the question, should Mars even have an atmosphere? The reason for that is that they think Mars lost most of its atmosphere a long time ago. And they also believe, based on their theories about the solar system, that Mars was in a rough part of the solar system billions of years ago and was getting pummeled with these huge impacts. Well, impacts are very efficient at causing you to lose atmosphere. So they think, they already say that 99% of the carbon in the carbon dioxide is escaped. Now, if you look at the numbers, they say, it was about 99% billions of years ago, and then it was another 1%. I think that's dangerously close. That's dangerously close to 100%.
Yeah, it is.
Again, I don't want to be dogmatic on that, but just as recently, it's just 2009, you had mainstream scientists saying, we're not sure Mars even should have an atmosphere. So that's another possible indication that it's young. The moons of Mars, Phobos and Deimos, those could also be indications of youth because Phobos in particular is spiraling in toward Mars. Now, that's caused because of gravitational interactions between them, but there's this break-even point. Whether something spirals in toward the planet or away depends on how fast it's orbiting compared to the time it takes for the planet to spin once on its axis.
Okay.
So right now, Mars takes about 25 hours. Its day is about 25 hours.
Okay.
Phobos has an orbital period of about 8 hours. So 8 is at less than 25, so it's going to spiral in. Well, obviously, you can run the numbers backwards, okay? If it's closer today, if it's spiraling inward today, that means it was farther away in the past. And it also means that at some point, its orbital period would have been greater. And if you run the numbers backwards, eventually you get to a point where its orbital period would have been the same as the Martian day. That's the break-even point. All right, so the moon really can't be older than that because if it had been older, if it was older than that, it would have started migrating away from the moon. And once that happens, you don't really expect anything to change that. So there's a break-even point where it looks like Phobos, however, we're not sure exactly how long, but how long it would take to get to that break-even point, probably measured in tens of millions of years, it looks like Phobos can't be more than, maybe tens of millions of years old. Now, what the evolutionists would say, okay, well, maybe the moons are relatively young. Maybe they aren't as old as Mars. Maybe they got captured somehow and ended up in orbit. But there's a lot of problems with that. It's unlikely. The orbits ought to be a lot more elliptical than they are. And also, you need a thick atmosphere to slow them down when they get captured. And those things really don't apply.
Right.
In fact, the former chief historian of NASA acknowledged that these capture scenarios for Phobos, and I think for Deimos as well, are problematic.
Well, and it's just interesting because it sounds like we've talked about a number of things in this podcast and also in previous podcasts that you and I have talked about various things. There is a lot of evidence that gives evolutionists and uniformitarians a very hard time.
Yes.
And there's a lot of evidence that is continuing to go in front of us, and we say, oh, well, that makes sense. We were expecting something like that. Even if it looked a little different in some of our past theories, we know that things are going to continue to look young.
Yeah.
We know that there are going to continue to be signs of youth in different planets like Mars and in various things across our universe because it is young. And so that's going to, because the Bible says it is, and that's going to continue to just show itself. But as we wrap up, did you have any closing thoughts on just volcanism on Mars, or even just how this points towards the Creator?
Well, I'll just say this. The evidence for youth is getting stronger and stronger. There are a lot of Christians out there who unfortunately are under the misunderstanding that evidence for creation, and especially recent creation, is getting weaker and weaker, and that we're just being backed into a corner, and that we're fighting this losing battle, and we have
to be scared of new information.
That's totally wrong. It's totally wrong. Now, unfortunately, as far as popularity is concerned, I'm afraid creation is becoming less popular because of what it implies about us being accountable to God. But as far as the evidence is concerned, it's overwhelming. I mean, our solar system really does look young.
So what would you say an encouragement to believers with that in mind, with the evidence just being very strong? Sometimes the popularity aspect, we hear that more. We hear people saying, you're wrong, you're wrong, you're wrong. There's no evidence, there's no evidence, there's no evidence. We hear that just matter-of-factly or even angrily from the other side. So what would you say, kind of with all of this in mind and what you just said about the evidence really piling up in favor of creationism, what would you say to encourage believers?
Well, you don't need to be intimidated. And, it's really, if you think about it, ridicule is probably the most potent weapon I think the other side has. They don't really have good arguments, but they can sure ridicule you. And unfortunately, we don't want to look foolish. And sometimes we may have to say, I don't know the answer to that. And that's okay. But what we're finding as we get more and more data, we're seeing the evidence for recent creation is getting a lot stronger. It's not getting weaker. And we're getting to the point now where I think we may have the potential to explain things that used to people thought were unanswerable. These were unanswerable questions that could not be addressed by creationists. And I think we're making real progress in answering some really tough questions. And that's what we do at ICR. We answer the tough questions nobody else wants to tackle. Yeah, the stuff that people think you can't answer. Well, we're finding, we can answer them, and we're doing it.
Well, I love that you and the other scientists who work here at ICR just dive in with courage, because that is hard. And there are a lot of loud voices speaking up against us and against other creation ministries and individual believers who stand up for creationism. But God is right. So we can be confident that we are as well, not in a proud way, but just in a way that glorifies our true Creator, the Lord Jesus Christ. And we can spread that word to other people with confidence, because we know that also the evidence backs it up. So that's hugely encouraging. So thank you so much for being with us today, Dr. Hebert. This has been hugely encouraging.
Thank you. Thanks for having me.
And to our viewers and listeners, we hope that this has been informative and encouraging to you. Just hearing how the celestial bodies here are still cooling off, and that indicates that they're a lot younger than is commonly believed, and that goes to confirm the Bible that we have put our faith and trust in. So hopefully this has been encouraging and helpful for you as you tackle some of these topics in your own mind and perhaps with people you know. Be sure to like and subscribe. We always highly recommend that people subscribe if you enjoy our content, so that way you can be the first to hear about new content that ICR puts out. And for now, I'm Lauren, and we'll see you next time on the Creation Podcast.
We want to say a huge thank you to our members and patrons. If you'd like to see your name here and unlock perks like early access to our podcasts, members-only polls and live streams, behind-the-scenes footage, or exclusive video content, links are in the description below.